Good evening, sir.
Good evening, everyone.
Good evening, sir.
Good evening. Good evening. Just guys, 2 minutes. We're gonna start the class. I would suggest please go through the notes once. I think uh, overflow, volume, and all we were discussing in the previous class. The last thing. All right, everyone. So in the previous class, we discussed about volume overflow. So I'm here giving one question directly on that. Then we will discuss some new things. I hope the question is visible to everyone.
Yes.
Yeah, please go through this question.
Good evening, sir.
Good evening, Mira. Bhavesh, this is the first question I have given. Okay, so please go through it.
Sir, is there a coefficient for water?
Uh, the gamma value is given for actually there is mercury, beta. There is no water.
Oh, okay, sorry.
There is a beaker which is made up of glass. So alpha of glass is given. And in the second part, it is filled with mercury. So that gamma value is given. Okay. Shri, correct, beta. Isabel, beta, please check your calculation. Gorangi, correct, beta. Arinja, I think Arinja 1 0. Just check in the calculation. I think you missed 1 0.
Yes, Siraj.
Yeah. Bhavesh, your answer is in milliliter or what?
Sir, first one is in centimeter cube.
Millimeter. Milliliter, actually.
Yes, sir.
Okay.
And second one is also in centimeter cube.
Yeah, got it. Fine.
Sir, so are they correct?
Yeah, fine. So, everyone, the question is quite straightforward. I'm sure all of you know what formula you have to use. It's just about the calculation. Uh, and the values are like this only. So you have to multiply and you have to practice these questions. So in the first question, it says that simple question, 1 liter is the volume at 0 degree, beaker volume at 50 degrees. So obviously we will gonna use gamma of beaker. So gamma of glass will be 3 times of alpha of glass, which is I think 24.3 into 10 to the power.
Is the second answer correct?
Wait, beta. Yeah, Shri, correct. So approximately you can take it as 2.5 into 10 to the power minus 5 per degree Celsius. This much round off you can do. Now, because for volume we can't use alpha, we have to use gamma, and this is the relation we know. So volume of glass at 50 degree will be 1 plus 1 plus 3 alpha, which is 2.5 into 10 to the power minus 5 into the rising temperature, which is 50. And if you solve this, you'll get 1.0012455, I think, liters. This is the volume of glass you will get at 50 degrees Celsius. Now, the second part of the question says that if mercury is filled at 0 degree, what will be the mercury overflow when the temperature is 50 degree? You have two ways of solving this. You can get the volume of mercury at 50 and you can subtract it. You'll get the answer. Or you can directly use the overflow formula, which we have discussed in the previous class. So overflow volume will be V naught gamma of mercury, which is 1.82, or I can take it as 18.2 into 10 to the power minus 5. And this is gamma of class, which is 2.5 into 10 to the power minus 5 into 50. Now, mind you, this answer will be in liters. Okay. So the overflow volume, when you calculate it, you will get approximately 8 into 10 to the power minus 3 liters. So basically it will become 8 milliliters. This will be the answer, or 0.78, 7.8 something. So I have rounded off to 8. So this is the overflow volume. Now guys, are we clear with this question? Tell me fast so that I can move to the next point.
Yes.
sir.
Yes, sir.
All right. So guys, I'll tell you one thing. This chapter, this thermal expansion thing, it is one of the topic which is very related with other chapters. Like there is a chapter called properties of solid, which you will learn in mechanics. It will come once you are done with, I think, work energy and all. So stress, strain, those things you have not done yet. So that's why those things I'm skipping. But I'm not saying that I will not do it. Once you are done with those topics in your physics 1, I will again take an extra class or something, and I will do all those questions and all those topics together. So if in books you find like thermal stress is given or other type of question is given, which I have not taken now, please don't feel like I will going to skip those things. Those are very important. But right now I'm not doing, because if I'm going to take that topic, I have to explain you whole chapter. So obviously, and that part of the and that portion is not which I'm going to teach. It's going to be done by the other faculty, which is sir is doing. I think motion in 2D. So very soon he will come to those topics also. So is this clear? So there are some things which I'm going to skip as of now, but later I will do it. Okay. Now here is one more thing. Time period of pendulum. Look, this is also something which you will learn in oscillation. But I'm sure that if I give you the formula, you will understand the part which is required for thermal expansion. Okay, so time period of pendulum, you all know what is a pendulum, but obviously you don't know what is the time period of the pendulum. So if I tell you that time period of the pendulum is 2 pi under root L by G. G is our acceleration due to gravity. L is the length of string. Length of string. This much only information is required. So now I told you the formula. Now I know you guys are smart enough to understand how time period, T is the time period of oscillation. So basically, if you understand this much, then it will be very easy for me to explain what will going to happen. Tell me one thing. Here capital T is time period, small t I am taking as temperature, just to avoid the confusion. If I increase the temperature, what will happen to the length?
It will increase.
Length will increase. And if length will increase, what will happen to the time period of
It will
oscillation?
also increase.
It will also increase.
Time period will also increase because time period depends on the under root L. Now, if time period of oscillation increase, our pendulum will become faster or it will become slower.
So it will become slower.
Slower.
Obviously, it takes more time to oscillate, so it becomes slower. It will slow down. It will become slower, and since it becomes slower, so it will lose time. Now, let me explain how it will lose time. Suppose you have calibrated your pendulum for 20 degree. So at 20 degree, pendulum, one oscillation, it takes 1 second. Correct? So if in 60 oscillation, you will count 60 seconds. Got it? At 20 degree. Now suppose same pendulum you are using at 40 degree. Now at 40 degree, for same oscillation, pendulum is going to take something more than 1 second. Let's say 1.1 second. Clear now?
Yes.
Earlier, what 1 second you were measuring, now 1.1 second you will count one oscillation. So for 60 oscillation, pendulum is not going to take 60 seconds, it's going to take 1.1 into 60. Are you getting my point? So what you are
Yes.
counting as 60 seconds is not 60 seconds, it is more than 60 seconds, so you have lost time. Is this point clear to everyone how pendulum, when the temperature increases, will lose time? All of
Yes,
you?
sir.
Can you
Is this
explain this lose
Yes, sir.
time thing?
who was this? I didn't get the question.
I'm asking that can you please explain this lose time concept again?
Yeah, sure. Why not? That's why I asked that if it is not clear. Abhijay, right?
Yes, sir.
Abhijay, what I said is at 20 degree, let me take the example and write it here. At 20 degree, one oscillation, let's say, takes 1 second. So 60 oscillation will take 60 seconds. You will count oscillation and you will implies that 60 second and 60 oscillation are equivalent. Now at 40 degree, I'm just assuming, okay, it's not real data. I'm just taking for an example to make all you understand. One oscillation will take more than 1 second. So let's say 1.1 second. Now beta 60 oscillation will take how much time? It will take 60 into 1.1.
1.1.
But how much you will measure? You will only measure 60 seconds now. Why? Because your each oscillation is equivalent to 1 second. So in actuality, how much time you should measure? 60 into 1.1. But what you are measuring is 60. So the difference will be the time lost.
Okay, sir.
Got it?
Yes, sir.
Okay. And please don't shy away in asking something if this is not clear. I'm very glad when Abhijay or other girls or guys ask the doubts. That means you guys are at least listening. You don't ask if you don't listen. Simple. Okay, everyone. So we are clear with this, right? So same thing implies if we decrease the temperature, the reverse will happen. Length will decrease, time period will decrease, pendulum will become faster, right? It will gain time. Instead of 1 second, it will finish the oscillation in 0.9 second. So what you will measure as 60, it is less than 60. So you have got or you have measured extra time. So that reverse part is clear to everyone?
Yes, sir.
Okay, now let's come to the maths. And maths, I'm sure you will get it. What is the time period formula? Time period is 2 pi under root L by G. This is at some temperature T1. Let's say at temperature T1 plus delta T, our length will become, this is at temperature T1 plus delta T. So I want to know how much is the change in time period. So what I'll do, T2 minus T1. So this will be 2 pi. I'll take root L by G common. So what I will left with is, I left with 1 plus delta L by L power 1 by 2 minus 1. Is this clear to everyone what I have written? All of you, are we clear? I have actually subtracted these two and I have taken 2 pi under root L by G as common. So here L was there. Delta L by L we have to write because there was no L here, but we are taking common from everything. So this is what it will look like. Okay. So actually, this is delta T. And this is our original time period. So change in time period equals to T. And here we have L plus delta L by L ka power 1 by 2 minus 1. Now we know that delta L is what? Thermal expansion formula. So delta L by L is basically alpha delta T. Now guys, we have a power of 1 by 2. What we gonna use here? Which mathematical formula? Alpha is very small. So what we gonna use here?
Binomial expansion.
Binomial.
Yes, binomial expansion. Very good. Why alpha is very small? We know that alpha is in the range of 10 to the power minus 5. So what we gonna write here? Delta t equals to t 1 plus, we will multiply the power, half alpha. Sorry, here my mistake. I should write small t. Otherwise there will be confusion. This is time period, this is temperature. In books you will see theta. Okay, minus 1. So 1 and 1 cancel. What formula we are getting? We are getting loss or gain in time equals to half alpha delta t into original time. Again, let me explain. Delta small t is what? Rise or fall in temperature. It could be both. Delta, this is loss or gain in time. And what is capital T? It is the time period of the oscillation. Everyone, are we clear with the formula?
Yes, sir.
All of you clear? All right. So
Could you please show the expansion in is 2 pi root over L by G taken
yeah.
common?
One second.
Yes.
This one you are asking?
So this T2 minus T1, yes.
Yeah. Okay. Tell me when you're done.
No, sir, I was asking, could you please show the expansion like, yes,
How I
taken
have written
common,
it?
yes.
Okay, sure. What I have written, Shri, 2 pi. Let's say root g is common now. So I can take root g out, right?
Yes,
So
sir.
what I will left with?
Sir, root over L plus delta L minus root L.
Yeah, I want to take root L also common. So could I multiply L and divide by L with delta L? So that I can take root L common from this, right? So if I
Yes.
want to take root L also common, so it will become root over L by G. And here L was available under root. So I will only write 1. Here L was not there, so I have multiplied and divided by L. So what I will get here? Delta L by L and over to the power 1 by 2, right? That is root only. And root L I have taken common, so
Yes, sir.
what I left with here is 1.
Okay, sir. Thank you.
Got it?
Yes.
Okay. All right. So, okay, let me take one question on this. All right, guys, it's a straightforward question. Please solve it. Shri, they are asking for beta in a day. I think you have calculated for one oscillation.
Okay, sir, I made a mistake. Thank you.
Done, sir.
Bhavesh, I think just double of that you will get what you're getting. Just check your calculation once.
Sir, how do we calculate per day?
Beta, in a day you will have 24 hours and per hour you have 3600 seconds. Got it?
Yes, sir.
So you have to just multiply with that. Yeah, Bhavesh, Shri, correct.
Sir,
Bhav-
Maya.
Sir, it is
Bhavesh, correct. What you got originally was correct. Shri, correct. Isabel, I think slight difference in the answer. Bhavesh, what you have answered me previously was correct because each oscillation is taking 2 seconds now. So it's fine. Arinsha, beta, check your answer once. Manushri, correct, beta. Isabel, correct. Abhijay, Gorangi, just half of that, beta. Yuvraj, correct, beta. So here, as I told, loss or gain. So obviously, first of all, temperature is decreasing. So if temperature is decreasing, there will be gain in time, right? And that is half alpha delta t into time. So per day, they are asking. So half into 1.2 into 10 to the power minus 5 into change in temperature or drop in temperature is 30. And in one day, you have 24 hours and each hour having 3600 seconds. I think if you multiply it, this is what we'll get, right?
Sir, in
Yes,
the
sir.
formula you used capital T. Is that not the time period of the first oscillation?
Capital T is beta time period or time for in which you want the gain or loss. Suppose if you want the gain or loss in one oscillation, you will use 2 seconds. Got it? If you want to, here they are asking for gain or loss per day. So that's why we have taken the total time in a day. If they ask that what is the gain or loss in only one oscillation, then we will use this. Clear, beta?
So
Okay.
movement will be minus 30.
Sorry.
So I want the delta, the change in temperature to be minus 30.
Minus 30 I have not taken because I've already used drop in temperature equals to gain in time. That's why.
Okay, sir.
And it's very weird to write time in negative. That is why. Okay. All right. So everyone, now I'm going to share some of the questions which come in PYQs, recent PYQs on the topic that we have done in these 2-3 classes. Okay. So please one by one go through them. And as I said, few questions I have left, which we will do later. So these are the questions. Okay. So before I'm going to this, please tell me, have you guys done errors? Unit
sir.
measurement errors you have done?
No, sir.
Errors you have not done. Okay, fine. So let me take the other question because this one. Okay, let me take this one. Okay. Okay, before we gonna take this question, let me just give you an idea. Resistance thermometer works similar to how our temperature scales work. So here, if you see, 0 degree is corresponding to what resistance? 80 ohm, right? So R 0 degree is 80 ohm and 100 degree is 90. And we know that in class 10th, you all have learned that resistance of a conductor is directly proportional to temperature, right? So if our temperature scale formula is this, and I want to write similar values in terms of resistance, what I should write on the right side in terms of resistance? Could you use the relation and tell me what I should write on the right side?
So will it be R minus 80 divided by 10?
R minus 80 by 90.
Can we
O
write
minus
R
80.
resistance at T degree Celsius minus resistance at 0 degree Celsius divided by resistance at 100 degree Celsius minus resistance at 0 degree Celsius. Is this making sense to all of you?
Yes, sir.
Please write it and solve this question. Correct. Gaurangi, Shri, Bhavesh. Isabel, I think something wrong with your answer. Arinjya, correct, beta. Manushri, please check your answer. I think you have missed. Himanshu, that 8 is by mistake or that is the temperature you're getting? You should get less than. Yeah, please check. So here we'll just use this formula. So T we want, right? So we'll write T upon 100 basically equals to 86 minus 80 divided by 90 minus 80, which is 10. So temperature we are getting as 60 degrees Celsius, which I'm sure is clear to everyone. Yeah. So, all right, let me take another question. Uh, Actually, there is some problem. It's saying that it's not fitting. Wait. All right, I'll write it on the board. There is some error. It's not able to paste it. Just one sec. Yeah. So there was a question in JEE to 2024. The question was again platinum resistance or platinum thermometer.
Sir, it is of mains or advanced?
Mains beta. I'm giving mains question. Advanced I will take later. Okay. So ice point 8 ohm and steam point. So I'm giving all only the relevant datas. 10 ohm. They are asking for resistance at 400 degrees Celsius.
Sir, only this much is the question.
Yeah.
Sir, the metal here is platinum, na?
Yeah, platinum thermometer. Isabel, correct. Aradhya, correct. Shri, correct. Himanshu, Arinjay, correct. Bhavesh, correct.
Excuse me, sir.
Yes, Himanshu?
Sir, can you please again explain that relation?
Yeah, I will. Gaurangi, please check your answer, beta. Abhijay, correct. Himanshu, here, what I have written is using the relation of resistance is directly proportional to temperature. This is the temperature scale, how we write the temperature scale of any unit, right? So
Yes, sir.
replacing the temperature with the resistance is what we have done because they are both proportional. So instead of T, I can write K times of R, right?
Okay,
So
sir.
that is what I have written. So at 0 degree, you can write the resistance of 0 degree. This resistance you have to calculate. I think steam point resistance is also given. So you put everything, you'll get the RT, which is T is 400. Clear?
Sir, is my answer now?
Yes,
I
sir.
made a mistake.
Yes, Gaurangi, correct, beta. So the answer here is, which all of you have given me, 16 ohm. So we'll write 400 divided by 100 equals to R 400 minus 8 divided by 10 minus 8. Okay. All right. Let me take another question here. Question is solid metallic cube of total surface area 24 meter square is uniformly heated. Rise in temperature equals to 10 degree. Calculate increase in volume. Alpha equals to 5 into 10 to the power minus 4 per degree Celsius. JEE means 22 question. I'll give the options also. That will make things easy for you all. Question is clear to everyone?
Yes, sir.
Okay, please solve.
Sir, what is CC in the options?
Centimeter cube beta. Instead of centimeter cube, I've written CC. Both are same thing. Okay. Joinil, correct. Shri, correct. I may not able to take, actually I have taken, got some. Aradhya, beta, which option is matching? I'll take as many questions as possible in the class. The rest I will paste in the PDF and I'll send it in the group. So you can go through it, right? In the next class, we'll discuss that out. Abhijay, correct, beta. Aradhya, I think your unit is meter cube. Isabel, correct. All right. So the answer for this question is option B. Arinjaya, correct. Bhavish, correct. So here, 6L square is basically 24. So from here, we'll get L value as 2 meter. So volume will become 8 meter cube, or 8 into 10 to the power 6 centimeter cube. Change in volume is basically 8 into 10 to the power 6 into 3 times of alpha into delta T. So which will be this. Okay. Let me take another question. All right. So two different wires having length L1 and L2 and respective coefficient alpha 1 and alpha 2 are joined end to end, then find effective temperature coefficient of linear expansion. The options are 2 root alpha 1 alpha 2
The effective temperature coefficient means effective coefficient of linear expansion.
Yeah, effective coefficient of linear expansion of wire 1 and wire 2 is alpha 1 alpha 2.
Sir, what you have written after join?
End to end, beta. Shri Isabel, correct beta. Very good. Bhavesh, correct. Yuvraj, Manushri, correct. So here,
Can I
if
for the
you
option?
yeah. Okay, so if you solve this question, you'll get option D. Avijay, Joynil, correct. Okay. So what you have to do here in this question, since we are joining the rods end to end, so this is L1, alpha 1, alpha 2, L2, and basically effective, we have to take a similar rod. Alpha effective, and the length will be L1 plus L2. So we have to take the change and equate them. L1 plus L2 alpha effective should be equals to L1 alpha 1 plus L2 alpha 2. Simple. Because both rods are identical, so their expansion should be same. All right, let's take the last question of the class. The remaining some questions, as I said, I'll send it the group. Please go through them. Please try this one. All right, everyone. I'll just want to explain this question. I'm sure you guys are almost able to finish. So you have rod A and we have rod B. Both are expanding, and how much they are expanding it's given in the question. Bhavesh, very good, beta. So by the given information, I can get the alpha of A as, if I write this as 50 into 10 to the power minus 4 upon 25. By 100. So this will come as 2 into 10 to the power minus 6 per degree Celsius. And similarly, alpha B will become 40 by 40 to 10 to the power minus 6. So we'll get 1 into 10 to the power minus 6 per degree Celsius. Now these two are mixed and made a rod 3, whose total length is 50. Shri, correct, beta? So let's say A is having L length. So how much is left for B? 50 minus L. And combined together, this much is the expansion. So I can write delta L of rod is delta L of A, whatever length of A is there, plus delta L of B. Simple. So A is, or delta is 3 into 10 to the power minus 4. That equals to L into alpha of A plus 50 minus L into alpha of B into change in temperature. Just solve this, and when you solve this, you will get the value of L as 10 centimeter. So that is the length of A in the rod, and obviously B will have the remaining 40 centimeter. Clear? All right, everyone. So you have maths class after this. So thanks for joining. I hope whatever we have discussed is clear to everyone. In the next class, we're going to take some new topic and we'll solve some new questions. Bye-bye. Thank you for
Thank
joining.
you, sir.
Yes, sir, guys.
Thank you, sir.